Alright, let's start. Today we're going to be identifying the particles in an atom, the atomic number, and the mass number. So if you haven't taken out your periodic table, go ahead and take out your periodic table. And the first thing we'll be doing is periodic poems. Number one, your brother or mine. So find an element name and a symbol that goes with your brother or mine. Number two, proud to be an blank. Find a name and symbol that might go with proud to be a blank. Number three, another word for police. Police. Number four, this man followed the yellow brick road. And number five, your first car may be this. Your first car may be this. So go through the periodic table, see if you can find an element name and a symbol that goes with these clues. Your brother or mine? Max. Bromine, that's correct. Very good. Bromine. Ha 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 ha. Proud to be in what, Billy? American. American, yes. American. Okay, police. Another name for police, Katie. Copper. You got it. Copper. Good. This man followed the yellow brick road. Ethan? Tin. The Tin Man from The Wizard of Oz. And your first card may be this. There's two possible answers. What do you think?
Like copper and lithium or something.
Okay, yeah. I didn't think about that one.
Silver.
The color could be silver, but that's not what I'm thinking of. So, y'all keep looking. Morgan?
Cobalt?
That's a good one. I don't have that on the list, but there's three possible ones. Then cobalt, that's a type of car. Good. What else, Max? Think about types of cars. You may not know different types of cars. Emma?
Vanadium?
Nope.
Titanium?
Nope.
Van?
Nope. Emma?
Thallium?
Nope. Tammy?
Rhodium?
Kenna?
Strontium?
Nope. One more guess. Nope. Sophia? No. Okay. Mercury and neon. Mercury and neon. These are two types of cars. Mercury and neon. And cobalt. Yes, let's not forget cobalt. Mercury, neon, and cobalt.
What's the abbreviation?
I think CO for cobalt. All right, when you're done with that, we are going to move on to the Addams Family PowerPoint.
They're tiny and they're teeny, but smaller than a meanie. They never can be seeny. The Addams Family, they're so small. They run like a ball. They make up the air, they're everywhere, can't see them at all. they surround the Addams Family. Theirs are small, they're round like a ball. They make up the air, they're everywhere, can see them at all.
Ready to try it again?
They're round like a ball. They make up the air, they're everywhere, can see them at all. Together they make gases and liquids like molasses and all the solid masses. The Addams Family, they're so small, they're round like a ball. They make up the air, they're everywhere, can see them at all. Neutrons can be found where protons hang around. Electrons they surround the Addams Family. They're so small, they're round like a ball. They make up the air, they're everywhere, can see them at all.
You'll need this with your periodic table. Okay. We'll add it to it in a little bit. You're going to video while they do this. Up close, okay? A minute. Okay, so on your sheet, we're going to start with the 4 arrows that are pointing to the blanks. And these are the items in each box for each element on the periodic table. So the first arrow is pointing to the 8 in the box for oxygen. What does that represent? What do you think the first arrow is? What do you think the first arrow is? Kenna?
Atomic number.
That is the atomic number. Good. Go ahead and write that in. The second arrow is pointing to an O. What is that?
The symbol.
Yes, that is the symbol or the element symbol. The third arrow is pointing to the word oxygen. What is that, Cammie?
Name.
That is the element name. Good. And then the fourth arrow is pointing to 15.99, the number in the bottom of the box. What is that, Sophia?
Atomic weight.
That is the atomic mass. Yes, the atomic mass.
Can we put
It might say weight, but whenever you put it on a, if you were to put it on a balance, that's what it would be, the mass. Okay, so what do these words mean? What does the atomic number mean? What does the atomic mass mean? Let's look at the atomic number. The atomic number equals the number of what or what? What or what? Sonia?
protons or neutrons?
Protons or?
Neutrons.
Protons or?
Electrons.
Protons or electrons. Because remember, if we have one positive, we must have one negative to make the morale of Matterville stable, right? Didn't we learn that? We have one positive, we must have one negative. So our protons and our electrons are equal to each other. For oxygen, how many protons and electrons do we have in an oxygen atom? In an Macy?
About 16.
Okay, if you add them up, yes, 16, but if you have protons and electrons, how many would you have of each in an atom of oxygen? 8, yes, very good. Okay, the atomic mass, the number at the bottom of the box, equals the number of blank plus blank. Morgan?
Protons plus neutrons.
Protons plus neutrons, because this is the stuff that's in the nucleus of the atom. The stuff that's in the nucleus of the atom. All right. We're going to do a couple together, and then I'm going to let you continue and help me out on the screen. So we filled in all of this stuff. Can someone come fill this in for me? Avery, go fill it in. Just the first 4 blanks for me. And you may have to press, yeah, you're going to have to press the pen before you do that.
This right here.
The pen? Yeah. thank you. And then can someone go ahead and fill in the blanks for the atomic number and the atomic mass, those 4 missing blanks? Cindy, can you do that, please? Okay, so let's take a look at the first one underneath the information that we just identified, which is oxygen. We're going to fill in oxygen on our blank because this is the word that is missing, the name of the element that is missing. And then it makes it easier for us to subtract and add if we have a whole number. So for the atomic mass, let's change this to a whole number. What would we change 15.999 to if we wanted to change it to a whole number, James?
16.
16, very good. So just cross that out and put a 16. All right, so our atomic number is where at in the box, Morgan?
It's the top number.
It's the top number, which is
8.
8. So I'll put 8 for my atomic number. The atomic mass is where at in the box, Caleb? It's at the bottom, so what am I going to put for the mass?
16.
16, good. Okay. So now we have to figure out what our number of protons, our number of neutrons, and our number of electrons are. But if we look back up here, the atomic number and the atomic mass give you a clue of what these numbers should be. If you look back up here, the atomic number tells us that this is our number of protons and our electrons. So what is our protons for an element of oxygen, Katie?
8.
That would be 8, because we know that our atomic number in the top of the box is 8. If we have 8 protons, which are a positive charge, we also must have 8 of what else, Madison?
Protons. Electrons.
Electrons, yes. So we're going to go ahead and put 8 for our electrons, and remember this has a negative charge. Okay, we're missing our neutrons though. Remember, our neutrons are atomic mass. This is our protons plus our neutrons. Do we know that we already have 8 protons? Yes?
Yes.
So 8 plus what is going to give us our atomic mass, which is 16? 8 plus what is going to give us our atomic mass? Max, what are we missing for our neutrons? 8, yes. So 8 protons plus 8 neutrons gives us 16. Thank you. And then can someone go ahead and fill in the blanks for the atomic number and the atomic mass, those 4 missing blanks? Cindy, can you do that, please? M&M model of the atom. This is going to be our M&M model of the atom. And we need to understand what we're going to do on this before we start. If you have a bag of M&Ms, how many different colors are there?
6.
There are 6. What colors do we have?
Red,
orange,
purple, yellow,
Green,
blue,
yellow,
brown,
and blue. Today you're only going to need 3 colors. So you will take 3 of these colors, and your shoulder partner will take the other 3 of the colors. You only need to take 3 colors. Once you get your colors, you're going to put in the blanks here, what color you're going to be using to represent protons, what color you'll be using to represent neutrons, and what color you'll be using to represent electrons. So let's pretend that Miss Birdsong has her colors. And I'm going to use, let's see, I'll use red for my protons. For my neutrons, I think I'll use blue. And for my electrons, I will use green. Okay. So now, give me an element on the periodic table of elements, something that's between 1 and 8, atomic number 1 and 8, and we'll start with that. Peyton.
Carbon.
Carbon. And what is the atomic number for carbon? 6. And what is the atomic mass?
12.
12. Very good. So this 6 represents the number of what or what? Katie.
Protons or electrons?
Protons or electrons. And what color are my protons supposed to be?
Red.
Red. And where do protons go in an atom?
In the nucleus.
In the nucleus. So I need to put 6 protons in my nucleus. 1, 2, 3, 4, 5, 6. If these are my M&Ms, this is where I would put them. If I have 6 protons, which are positive, I must also have 6 of what? Electrons. So let's look. My electrons are going to be green, right? So I need to put 6 electrons in my atom. The first energy level holds a maximum of how many?
2.
2. So I'll put 1 here and 1 here. I've used 2 so far, but I have 6 total to use. So how many do I need to put on the second energy level?
4.
4. 1, 2, 3, 4. And I'm done with my protons and electrons. Now I need to go back to my atomic mass. My atomic mass is 12. That means how much stuff I have in my nucleus. I already have 6 protons in my nucleus. So how many neutrons do I need to add to my nucleus to get 12 total? What do I need to add, Reed? I need to add 6 more. Very good. So I'll add 1, 2, 3, 4, 6. Now I have created a model of carbon using M&Ms. Do you understand? Okay, I want you to represent 4 elements from the periodic table using your M&M models. The first thing that you'll have to do is divide up your M&Ms. You get 3 colors. Your shoulder partner. Your shoulder partner will get the other 3 colors. You'll write in what colors you're using for which particles in the atom, and then you're going to represent 4 of the atoms from the periodic table. Okay.
I modeled beryllium. Oh wow! No, that's not right. They're both nucleus.
There's 1 proton, there's 1 electron, and there's no neutrons because
You said I did it right.
well, you didn't.
Closure today. Let's talk about what we learned. If you look on the board for our objective, we've identified the particles in the atom. Those are the protons, electrons, and neutrons. We know where the atomic number is located at in the atom, the element box, and we know where the mass number is located at in the element box. So those are the things that we needed to make sure that we understood today. Just to wrap up our day, we're going to do clever catch, and we'll pass the ball from one person to another. When you get the ball, I'll tell you which question to read, and then after that, you can pass it to somebody else. It has completed a little bit, so let's load up.
This is that
Okay, starting. Okay. Right pointer, what do you have?
Acceleration depends.
What number?
3.
3, what do you have?
Depends upon
depends on, yes, both direction and speed. Very good. Pass it. Okay, Ethan, left pointer, what do you have?
Number 76.
What do you, okay, what's it say?
If a wood block is in a jar and the jar is broken, what will happen to the volume and shape of the wood? Is there like any answer choices?
Okay, well think about the wood block. If it's in a jar, if you break the jar, what happens to the wood block?
It'll stay the same.
Yes, it will stay the same. Very good.